So, okay, let's go over the material. We already learned chapter 10 and chapter 11. So chapter 10 is about parametric equations and how to use parametric equations to find the lengths and curves. And also there's an important section about polar coordinates. Polar coordinates are just special polar coordinates. Actually, the polar equations that give you special parametric equation for the function for the curve. So let's do some exercise from the sections. Right, so each chapter there was a review set, a review page, which is on page 730, 731, right? So what kind of problems will be discussed? Definitely there will be one problem on polar coordinates, okay? And the polar equations. Another one could be more general, just say find the, understand the general parametric equation for the curve. So we, let's take a look at the first problem from the book and just pick up some problems to discuss. So first of all, yeah, let's take a look at the equation x equals 2 cosine theta and y equals 1 plus sine theta, okay? And there's no restriction on the theta. What we have to do is to sketch the parametric curve and the curve parameterized by these equations, okay? Eliminate the parameter to find the Cartesian equations of the curve, okay? So, so how to do this type of problems? Well, if you can eliminate the parameter to get Cartesian equations, that helps you to recognize the curve, so much easier for you to draw the graph, okay, in some cases. So we're trying to solve the problem as follows. See, we know cosine square theta plus sine square theta equals 1, right? We use this equation to find the relationship between x and y. So x cosine theta is going to be half of x. Sine theta is going to be 1 minus y minus 1. So therefore, we get half of x squared plus y minus 1 squared equals 1. So this is an ellipse. Okay? It's an ellipse. Okay. So you can ellipse. The center of the ellipse is going to be 0 and 1. Okay. So sketch the graph. Since there's no restriction on the theta, yeah, if it's possible, get the Cartesian equation. Otherwise, you have to choose a special values for t. You compute the values for x and y, and you plot them into the xy plane, and then you use your imagination to connect them. Okay. So now, if you know this is a equation for ellipse, then this is a center, right? Then it's easy to solve the problem. So when y equals 1, x is going to be plus or minus 2. So this is a 1, this is a 2, negative 1, right? So x will be these 2 points. Okay, when x equals 0, y is going to be y minus 1 is going to be plus minus 2. So could be 0. So this is a curve. This is ellipse. Okay, how do you determine the upper bound and lower bound for ellipse? So you can set the x to be 0. Then y minus square equals 1. So y minus is plus or minus 1. Y equals 1 plus or minus 1. So you have 2 values. either 0 or 2. So that's why you get 2 points on the elliptic. Okay, this is how do we get from, and the y minus 1 equals 0, then half of x squared equals 1, x is going to be plus minus 2. So you have a negative 2 positive, right? And 2 and the 1, negative 2 and the 1. So that's why you get 2 vertices of the ellipse. So this is a curve, and then orient go in that direction. So we can also mark it where the theta is 0. When theta equals 0, x equals 2. So this is the place where theta is 0. When theta increases, and then here theta equals pi over 2. Right? So you get the complete circle and also get the graph. You just needed to know the 4 points on the ellipse. That's enough. Okay? So this always trying to use Cartesian equations possible and to help you to draw the graph. Now, my next question related to the question is find the tangent line at, find the tangent line at the point of the curve where theta equals pi over 4, for example, okay? So somewhere theta equals pi over 4 is somewhere here, and you're going to find the tangent line, okay? So you have to find that point first, okay? You have to find the point first. So when theta equals pi over 4, x is going to be 2 cosine pi over 4, which is square root 2. Y equals 1 plus sine pi over 4, which is 1 plus square root 2 over 2. So you get these 2 points. Right? Now question, how do you find the slope? The slope, okay? The slope, you will, this is supposed to be the derivative y with respect to x when x equals square root 2. But we're not going to do that. We don't want to solve for y in terms of x. It's too complicated. We still use the parametric equations for y and the parametric for theta. This is general. Then when theta equals pi over 4, okay, that helps you to do the computation, And then the derivative of y with respect to x is cosine theta. The derivative of x with respect to y is negative 2 sine theta. Okay, so you will get square root 2 over 2, negative 2 times square root 2 over 2. So actually that cancels out. You only get negative 1/2. All right. Therefore, so the equation for the tangent line is y minus 1 minus square root 2 over 2 equals negative 1/2 x minus square root 2. Okay. So you can simplify further. Then you move all the terms to the right hand side. So you get negative 1/2 x plus square root 2 plus 1. So that's the equation. Now we look at the picture. Okay. So the theta here is this angle. Okay, I just want to mark it. Now the so-called polar curves, those are the curves described by polar equation. The polar equation in the polar coordinate system, okay, and so you can, yeah, polar equation and parametric equation, what's the difference between them? Okay. Polar equation just only have one single equation, okay? For the same curve, you can have a polar equations, parametric equation. Parametric equations, x equals x of t, y equals y of t, okay? So we are totally in a different system. We are here, we are in the, yeah, in the xy coordinate system, okay? But if you want to draw the graph for this equation, so actually, if you want to draw the graph for this equation, this is theta and r, okay? But when we draw the polar curve, we usually do not draw the graph of this function. We actually still draw the graph in the xy coordinate system, okay? We still draw the graph in the xy coordinate system, but x is going to be r cosine theta, okay? Y equals r sine theta. So this is a point x and y, and that's a theta, that's r. So the relationship, yeah. So here's r cosine theta, it's yi cosine theta. For every point in the xy plane can be described not only using x and y, it can also use I and theta and r, okay? You can use I, yeah, use a theta, r, and r, so if you have a curve, so a curve can describe by when your theta changes, right? When theta changes, the r changes, get longer or short. So r is a function of theta. So you can use r and you can use the relation between r and the theta to describe the curve in the xy plane. Okay, so you can get a special, once you are given polar equation for the curve in the plane, right? In the xy plane, actually in the xy plane, then you can get parametric equations. Parametric equations. The parametric equations, if I equals, yeah, if I equals f of theta, then x will be f of theta cosine theta, y equals f of theta sine theta. So you get the parametric equations for the curve. Right? For the curve, you can describe it in many ways. You can describe it without using theta, okay? Just t, okay? You can also describe it using polar equations. Okay, let's look at the example here. Okay, this is the example, the circle with the radius x, x squared plus y minus 1 squared equals 1 squared, okay? Let's look at this circle. And there are a couple ways to parameterize it, okay? You can parameterize it in using this t, okay? This is the angle t, okay? So x equals cosine t, but y equals 1 plus sine t, for example, right? So when you, so that's one way to parameterize it. But I can also find the polar coordinates, right? So look, the same picture. I'm going to use this angle theta, use this r. Okay, at the given point, for a given theta, can you find the r? Okay, can you find r? Yeah, let's describe this curve, this circle, using polar equation. Okay. See, we can remember, here's x and y, right? So x equals r cosine theta, y equals r sine theta. So I put into the above equation r cosine theta square plus r sine theta minus 1 square should equal 1. Okay, so you get r square cosine square theta plus r square sine square theta minus 2r sine theta plus 1 equals 1. So 1 cancels out. I get r square minus 2r sine theta equals 0. It's not too bad. So I have r minus 2 sine theta equals 0. So either I equals 0, which means this is an origin. Okay, so I equals 0 or I 2 times sine theta. So I equals 0, just the point is the origin. But I equals 2 sine theta also gives the point of origin when theta equals 0, right? So this really describes the whole circle. Okay, so I equals 2 sine theta is the polar equation for the circle, right? And the theta is between 0 and 2 pi. You get a complete circle. And conversely, given a polar equation, you can use theta to parameterize a curve. Okay, remember, right? Then x equals r cosine theta, so I get r 2 sine theta cosine theta, which is a sine 2 theta, right? Y equals r sine theta. It's going to be 2 sine theta sine theta. I got 2 sine square theta. And then x equals sine 2 theta, and y equals 2 sine square theta is a set of is a pair of parametric equations for the circle. Okay, but this parametric equation is different from the above one. Yeah, different from above one. You see that, right? So quite different. Cosine t 1 plus sine. So for the same circle, you can describe in many different ways. But that t is a geometric mean of that t is this angle. I can use a theta. Okay, I can use a theta. Doesn't matter. But our theta here is going to be, yeah, this angle, right? This angle, see. Okay. So this theta is not different from that above t. So for the same curve, circle, you can play with that. You know, you have two different parametric equations, two sets of parametric equations. Okay, and the second one is I got from the polar equations. How to get polar equations? I use a Cartesian equation. If I give a polar equation, I can also get the Cartesian equations back. Okay, so this is a good example, yeah. And but using polar coordinates sometimes give you nice formulas. For example, like area formula. Yeah, you have a couple of formulas you have to, yeah, you have to remember, okay? So first of all, the length formula. The length formula, okay? So the length, a curve in the space. The length, this is C. The length of the C is the integral ds, okay? Integral of ds in mathematics, you use this notation. I put a C there, but I do not specify interval. But if you parameterize by depend. If it's parameterized by x equals x of t, y equals y of t, then this is going to be integral. If t is between a and b, that's going to be integral of, in that case, ds is going to be square root of x prime t squared, y prime t squared dt. So all you have to do is, okay, to evaluate this length using that formula. Okay. All right. So now, if, okay, if the curve is, if you are not given parametric equation, if you are given Polar equation, if I equals f of theta, okay? If I equals f of theta, that means you will get x equals f of theta cosine theta, y equals f of theta sine theta, right? Yeah, in some books that don't use f, because for simplicity, I'm going to just use r, okay? R over theta. Sometimes you're lazy, you don't want to write down theta here, okay? So R over theta. So now, if you use that formula, you plug into the above formula, if theta is between alpha and beta, then the length is going to give up using this parametric equations, and right, and then you have a formula which is given. You know, I just want to give you the formula, the arc length formula. Okay, so that's given in the book. It is good, very simple, just alpha and beta into 1 plus r squared plus and r prime squared d theta. Okay. Yeah, all the cosine sine theta is gone after you simplify. Okay. If you can also use that to find the area formula. Where is the area formula? It's half of the square. Yeah, but if the region is inscribed by a curve which can be parameterized by Polar equations, then it's determined by Polar equation, then you can also have another formula for the area. Okay, so for this sector, okay, here's theta equals alpha, and here's theta equals beta, and this is an arbitrary, you know, I equals r theta. Okay, then the area of that region D is going to be integral just equal half of that. Okay, but this is it's not from a general equation. That's where it's from the definition of the area. We partition the region into many triangles instead of rectangles, and we calculate that. This is the limit. Okay, so that's about, if you use parametric equations, you cannot get this equation. So some students was wondering if I use a parametric equations instead of yeah, if you use a parametric equations, this is what we're going to study actually for the closed region. Okay, that's a D. If the parametric equations is given by is a parametric equation is given by x of t, y over t, and y equals y over t. and T is between A and the B. If it's closed, then you do have a formula for that, okay? So what is that formula? You'll be surprised too. Okay, the formula is going to be area is going to be, it's mentioned in the book, but it's not proved in the book, okay? So where it is, I remember here it is, in somewhere in the book. I think the previous section. All right, let me give you the formula. So that is going to be I believe that, let me check. It's going to be the integral. It's from A to B. You can use a single function, or you can use a okay. This should be minus, this is plus. So it's quite a surprise. This integral gives you the area of that region, but we're not going to look at this, okay? Okay, let's continue working on the problems from that section, from that chapter. Okay, to review. Okay, so let's take a look at following problem. Okay, so find the area of the region enclosed by the curve I equals 2 cosine theta. Let me check. 2 sine theta. Okay. All right. So this is a final area. So we have to describe we know that this is a circle actually. If you don't know, then how do you understand the picture? So there's no restriction on the theta. So that means when theta is increasing, okay, when theta is increasing to pi, you get 1/2, okay, that's a theta. Then after theta pass pi/2, okay, you get the negative r. So actually, when theta runs from 0 to 2 pi, you actually draw the circle twice already. You have to pay attention to that. Okay, so notice that it's sufficient theta from 0 to pi. It's already covers the whole circle. Okay, then so that's important. So area is going to be half of the integral from 0 to pi, not from 0 to 2 pi, okay? And that is going to be half of r squared d theta. Yeah, this is true. But if you can convert it to the Cartesian equations, then you say, oh, that's just circles. I know that area is going to be pi immediately. That's also, you can do that, no problem. So that'd be 4 sine square theta d theta, and let's simplify it. It's a 2 sine theta d theta. Right? It's going to be 1 minus cosine 2 theta d theta. Okay. Okay. So the antiderivative will be theta minus sine 2 theta, and evaluate 3 endpoints, just pi. Okay, and that is not surprise. So we already know that the area of this circle is going to be pi. Okay. Okay, so we can find the length of the polar curve. Okay, polar curve still equals r times sine theta, but this time theta is between 0 and pi, already specified. Okay, so I assume that you don't recognize this is a circle. Okay, so how do you do that? So you have to write down the formula. The length is going to be integral from 0 to pi, and here r squared plus dr d theta squared. Write down this formula first. Then you put into the details. I'm not sure you can simplify 2 sine theta squared plus the derivative with 2 cosine theta squared d theta. So you will see that it's going to be just 2 squared. So in this particular case, 2 squared. Cosine square theta plus sine square theta is going to be 1. So the answer will be 2 pi. And that is just a circumference of the circle. Okay. Without, but the curve can be parameterized by general equations. Okay. So then, how to find the length of the curve? Here's the parameterizations: 2 plus 3, 2. Y equals hyperbolical cosine 3t. T is between 0 and 1. Find the length. Now this time the curve is parameterized by these 2 equations. Okay. So what you have to do is step 1, you write down the formula for the length. It's integral from 0 to 1, and the dx dt squared plus dy dt squared and dt. Okay. Then you differentiate. The first one is the derivative is 3 squared. The second one you differentiate is going to be 3 sine hyperbolic sine 3t. And the 3 can be taken out. 1 plus hyperbolic sine 3t squared, and that is going to be hyperbolic cosine 3t squared. And so the radical can be canceled out. And the antiderivative of this work sine 3t. And the value of 2 endpoints work sine 3. Work sine 0, 0. So that's all about the chapter. I think I went through all the problems. Now we come to the sequences. Okay. So remember, there was, there are different problems there, right, on the test. You already learned the integral test, the test for divergence. You list all the name of the tests. Okay. When you work on the problems on test 3, test 2, you ask yourself, have you used that particular method or not? Okay. If you haven't used the integral test, probably, right, probably have to use it somewhere. Okay. So you cannot use the same method to fix all the problems. That's a remember. Okay. There are some things you do that. Always use ratio test. I don't know why he's in favor of ratio test. Throughout, even the limit is going to be 1. Still jump to the conclusion, convergent. Okay, I don't know. When you say convergent, which one is convergent? Is the ratio convergent to 1, or is the series convergent, right? Okay, it's possible that that series is convergent, but your argument does not support. Okay, your claim, and we cannot give you any credits even. You cannot say I write something over there, but your argument's completely wrong. Okay, cannot give you any positive. Cannot give any information. It's not nothing to do with the proof. Only indicates you don't know how to do this problem. So I should give you negative points instead of positive points. Okay, even the answer is correct. It's convergent. Clear? Yeah. Right. So so what kind of problems will be on the test? Yeah, let's do some problems. Okay, this is from section. We did lots of them problems already before, right? There's a section called the strategy. Strategy for the convergence, right? So that process representation. Before that, we also have a section 11.7, right? Strategy for testing series. I did half of the problem already in the class. So look at that section, the lecture notes, okay? And they actually, yeah, we did already plenty of that. Don't just read it, okay? If you read read my solution, and you understand them, does not mean you're able to solve the problem by yourself. You do need a practice, okay? And if you eventually, it's harder to check whether your solution is correct. That's the problem, okay? Even I said that even the answer, the answer gauge's answer is just say it's convergent, but if your argument is wrong, who can tell you the argument? Nobody, okay? So what I suggest you to do is you don't look at my solution, just do the problem by yourself. Those problems we discuss in the class, okay? You cover the solution, okay? Then compare your argument with my one, okay? Maybe there are multiple ways to solve the problem. I usually list all the possible ways, okay? If your method, you prove that it's convergent, but it's not, I did not mention it. So ask yourself, is the argument is correct or not, right? Okay, if you're still not sure, then you can stop by Mac, or you can also stop by my office to ask Or you can, another way to do is, you know, if we can form a study group, you know, teach each other. That's also the way, the good way to explain to each other how do you solve the problem. Okay, that is very, but it's hard to find, find friends, you know, work together. All right, so let's take a look. Let's look at the following problems. Okay, we want to know whether this is a convergent or whether it's divergent. All right, so I have 3 to the n, 2 to the n, yes, 4 to the n. Okay. To me, this is obvious it's convergent. The question is how do you prove it? Okay, how do you prove it? There are actually many ways to do, but comparison test is the best method you can use. All the terms are positive, right? And you want, why do I see this is convergent? Because 2 to the n compared to 4 to the n can be eigenvector. You know, you can throw it away. So that you only get 3 to the n over 4 to the n, which is 3 over 4 to the power n. And I equals 3 over 4, which is less than 1, then convergent, right? So you can use the inequality, and that's going to be 4 to the n, right? And that's going to be 3 over 4 to the power n, that's my bn. So by bn, we know that this is convergent. Why? Since I equals 3 over 4, which is less than 1. Right? This is a geometric series. And obvious geometry series is convergent. So then that concludes that this is a convergent by the comparison test. Okay. Can you use a ratio test? No, difficult. Use a load test, because you see that's 3 to the power n then. But if you use a road test, you still have a trouble to deal with the denominator. Okay. Then if you use the wrong formula to simplify it, wrong algebra formula, you're going to lose more points of that because the argument is wrong. Even, you know, eventually prove this is not proof. Even we jump to conclusions, this is convergent. Okay. So comparison test is the best way to do. Sometimes you have to use a limited comparison test. The reason is if I change it to this, like a 4 to the n minus 2 to the n, I'm pretty sure this is always positive, the denominator, because it's always positive. So never worry about it. Now, you cannot use a comparison test directly because 3 to the n, 4 to the n minus 2 to the n is not going to be less than 3 to the n, 4 to the n. Actually, it's the other way around, okay? It's okay. So sorry, yeah. So the one on the left-hand side is convergent doesn't imply the one on the right-hand side convergent. So you cannot use a comparison test directly. But as I told you, 2 to the n is almost can be dropped, right? Compared to the 4 to the power n, it's really small. You know, 4n minus 2n, if you take a 4 to the n, it's 1 minus 2 to the n, 4 to the n, right? It's going to be 1 minus. So that number is very small, okay? But how do you prove this, right? So you still let Bn to be 3 to the n or 4 to the n, which is, okay? But this time you cannot say An is less than or equal to Bn. So you have to use a limit. You have to use a limit comparison test, right? So if you use a limit, then yeah, let's simplify it. N over Bn, and that will be 4 to the n, 3 to the n, okay, upside down, okay? That's the one note. And then you simplify, 3 to the n is already gone. And then you divide the numerator by denominator both by 4 to the n. And the limit is going to be 1 as n approaches infinity. So 1 is going to be non-zero, finite number. Okay, so the both convergence are equivalent. So sigma n is convergent if only if this is the convergent if and only if this is a convergent. And this is convergence guaranteed by the geometry series. Then that implies sigma n is convergent. Okay. Okay, so those two are convergent equivalent by the limited comparison. But sigma Bn is convergent. We already know that. This is by geometry series. So that in limited comparisons are almost the same. But sometimes you have to use a limited comparison test to give a good argument. Okay, clear argument, because you cannot compare directly. All right, so that's good. Right. You know, you say, oh, that's obvious. I know how to prove it. But I won't tell you that, you know, just try. If you know how to prove it, the question, ask yourself, how many different ways you can prove it? Okay. So when you do an exercise, just trying to find all the possible ways to prove it. Okay. Now you cannot use the ratio test. You cannot use the row test. Why? Because the limit is going to be 1, inconclusive. Okay. You can use a alternating series test. That's obvious. But I'm trying to use a different test. Okay. So we know that this is going to be 1 over n squared. Okay. So that means I can even change a little bit. You know, I can even put the +1 here. Okay, +1. Okay. Then this is going to be 1 over n squared. By the comparison test, this is a convergence. Why? Since this is a convergent by P series. Okay. So since this is convergent, it implies even you have a negative sign, this is a convergent. Right? And this is a by some theory. It's an absolute convergent actually. this is a convergent. Yeah, this is a convergent. Since this is convergent by the comparison test, right? You compare two series with positive terms. Yeah, this is also positive because they're both the values there. Comparison test can be only used for series with positive terms, not for the series with negative terms. For example, if I have a sine n over n squared, right? Just like that. You cannot use a comparison test directly. Okay? What is the way? Yeah, what is your idea to check whether it's convergent? Yeah. Okay. So you cannot use the integral test. You cannot use the ratio test. That's not what. You cannot use the root test. The only way you can do is consider this one. Okay. If this is convergent, then it implies that one. Now it's positive every time. Then you can. That is my n. Then this is going to be less than n squared. That's my p. Okay. Then it since this is a convergent. Okay, it's a finite implies this is a finite. Okay, we usually say convergent. Okay, it's a finite because all the terms are positive. It's convergent. Okay. Right. So once n is convergent, we still have to use the theorem. This will be convergent. Okay. There is a theorem using the absolute value. We don't have a name for that theorem. Okay. So you just say this is convergent. That's enough. Now this method does not work for all the cases. Like this one, we don't know. We don't know. Nobody. Okay, you cannot see the problem in the textbook because nobody can prove this is a divergent or this is a convergent. Right? It will be extremely difficult. It will be extremely difficult. Okay. All right, so we don't know. Okay, no idea how to prove it. If you have to write the proof, probably, maybe you can find on internet somebody prove it within 3-4 pages. It's hard to understand. Okay, but it's not an easy problem. Okay. Do we have a time for quiz? Yes, we have to take a quiz. It looks like. Okay.